Hello everybody, welcome to Virtual School Physics is Fun. Today we are going to continue with convex mirror. Okay, after learning concave mirror, so now it's convex mirror's turn. Convex mirror, the reflecting surface is on the outer surface. Alright, on the outer surface. So the focal point and the center of curvature is inside the mirror. Convex mirror is a diverging mirror, so all parallel light rays will be reflected and diverge and spread out from F, from focal point, which is inside the mirror. So we draw a dotted line to represent this line that is inside the mirror. Okay, so all parallel light rays will be reflected from F, which is inside the mirror. Now, to draw image of convex mirror, we need to learn the ray diagram. Okay, there are three rays rule that we need to know before we can draw the image. Ray number one, which I prefer to call ray P, similar to concave mirror last time. Ray P because it's parallel to the principal axis. So ray P will be reflected from F, from focal point. And ray number two, which I call it ray F, F stands for focal point. So ray F, this red one, because it passes through F. Alright, so when we extend it until it passes through F, so this part that is inside the mirror, we need to draw dotted line because it's not the actual ray. We don't see this ray. The ray cannot go inside mirror, right? So we draw dotted line. So we know that ray F will be reflected parallel to the principal axis. Okay, it is the opposite of ray P. Ray P, incident ray, is parallel to the principal axis and is reflected from F. Whereas ray F, the incident ray passes through F and the reflected ray is parallel to the principal axis. And ray 3 is ray C. C stands for center of curvature. So it passes through C. Right? So this ray C is reflected back the same way it comes from. Now it's reflected back along the same track that it comes from. Okay, so now we want to draw image of the convex mirror. So first we have the object and we draw a ray from the object. Ray must originate from the object. So ray P reflected from F, and then we draw a second ray, ray F. This is ray F. So if you extend until here, we see that it passes through F. So ray F is reflected parallel to the principal axis. And we learned that reflected ray, when they intersect, that is the position where the image is formed. But now you see these two reflected rays. They are not going to intersect anywhere in front of the mirror because they are diverging. But if we were to trace back inside the mirror, you see that? Yeah, so they intersect inside the mirror, behind the mirror. So this intersection of the two reflected rays inside the mirror is where the image is formed. So we draw the image here. Okay, so you can check by drawing the third ray. So ray C passes through C and then it reflected back the same way. So you see these three reflected rays, they intersect at the same place inside the mirror. So this is where the image of convex mirror is formed. So you see that the image is upright. Yeah, it's upright. and it is smaller than the object, is diminished. So this type of image which is inside the mirror is called a virtual image. Right? Virtual image. We will learn more into detail about the difference between real image and virtual image in another video. Okay, so this is virtual image. It is inside the mirror and it is upright, and it is also smaller than the object. So we say that the image is virtual, upright, and diminished. Let's look at the characteristics of image of convex mirror. Okay, so first, if the object is very far away, it's placed beyond C, it's behind C, so we draw ray P, and then it's reflected from F. We draw ray F, it's reflected parallelly. We draw ray C, it's reflected along C. So the intersection of these reflected rays is here. So the image is from here, right? So the image is inside the mirror. So we say it's virtual image and it's upright and it's diminished. What about if the object is nearer to the mirror? So it's between C and F. So look at the image. We draw the same way, draw the three rays the same way, and we see that the image is still behind the mirror or inside the mirror. So it is still virtual and it is upright and it is also diminished. Look at this case number 3. Now the object is between F and P. That means it's less than F. U is less than F. Draw the ray diagrams, draw the three rays, and the intersection of the reflected ray is still inside the mirror. So it is still virtual, upright, and diminished. Case number 4, U equals to F. Still the same. Last one, U at C. U is at C. Yeah, I mean the object is at C. U equals to F. Look, again it is the same. So what do you learn from here? You can see that no matter where you place the object, whether it's far away or it is near to the mirror, all also gives us similar characteristic, that is virtual, upright, and diminished. Virtual, upright, diminished image is always the characteristic of image of convex mirror. So the object distance does not affect the characteristic of the image of convex mirror. No matter where you place it, it is always virtual, upright, diminished. Only difference is if the object is nearer to the mirror, the image becomes bigger, slightly bigger, but it is still smaller than the object. Yeah, image becomes bigger when object distance decreases. Okay, but it is still diminished image. All right, so we conclude. Yeah, the characteristics of convex mirror does not depend on the object position or the object distance. Okay, that's all for today. We will continue with other lessons some other time. Okay, watch out for more videos. Thank you. Bye.